Okay, I think I'm going to get started so I can keep cognizant of everyone's time today. Thank you all for joining. Today we will be going through a webinar on the PSAB 3280 asset retirement obligations for public entities. My name is Michael Horobin. I'm a senior product manager in the hazardous materials and indoor environmental quality group, and I'm joined by my colleague Nicola Hooper, who is also a senior product manager in our environmental due diligence and remediation team. What is the PSAB? The PSAB is a public sector accounting board and is an authoritative body for establishing financial reporting standards for public sector entities. It's comprised of stakeholders from government, industry, and public sector management. And it publishes and maintains the public sector accounting standards, which is comprised of a large volume of standards that are continuously reviewed and revised. The sectors that are subject to the PSAs are all non-for-profit public sector entities. This includes all other levels of government: federal, provincial, territorial, local, municipal. It also includes public sector institutions such as social housing, school boards, hospitals, colleges, universities, and district service boards. For-profit crown entities such as hydro, liquor commissions are not subject to PSAs. PS 3280, or Asset Retirement Obligations, ARO. It's the asset retirement obligation that was first effective in April 1st, 2022. It's a legal obligation associated with the retirement of all tangible capital assets, or TCAs. It's typically triggered by legislation or by contract. It's done to recognize cost for retirement of these tangible capital assets and reported on financial statements annually. There are a couple other standards that are relevant depending on the sites you manage. PS 3260 is the liability for contaminated sites. That's typically ground soil. Yes, there will be a copy of the webinar recorded online for review afterwards. PS 3260, is liability for contaminated sites, and then 3270 is the soil waste landfill closure and post-closure liability. Your AR obligations, these are the activities that often result in the requirement for ARO: removal of asbestos or other hazardous materials from your sites, removal of fuel storage tanks, removal of sewage treatment plants or on-site sewage systems, removal of customizations / leasehold improvements, landfill closures, and also disposal of radioactive medical equipment, so X-rays or MRI machines. There are a few steps to a successful ARO. The first one is obviously compiling a list of all your tangible capital assets, so types of buildings, use, size, year of construction, that sort of details. Create an expectations for the type of ARO. So do you have asbestos? Do you have underground storage tanks? Do you store chemicals on site? All that sort of details. And then building the right team. So your facilities would be involved, your accounting team, your environmental, your health and safety department, all the people that might have a stakeholder in it. And then also using external resources when necessary, such as pension or other consultants and experts. Documenting your methodology of how you prepare your ARO. And also updating it on an annual basis. One portion, large portion, is the hazardous materials for your ARO, and that's what I'm going to speak to today. Main overview is what hazardous materials may be present in your building and where they may be found. Process to determine the remediation cost or removal cost of these materials prior to the retirement of an asset. And a few examples of how we get our cost estimates together. Hazardous materials can be found in multiple building materials. The main ones we look for are asbestos, lead in paint or other materials, mercury, PCBs, mold, stored chemicals, and bird or rodent droppings. Common use of asbestos. There's a long list. This is just a short one. These are going to be the most common ones you see in your buildings. Floor tiles, vinyl sheet flooring, fireproofing, pipe, boiler insulations, duct insulation, drywall joint compound, plaster, ceiling tiles, texture finish, mastics, adhesives, caulking, roofing. There's many, many more. We have over 3,000 documented products, and we have cutoff dates for most products, but not all products. So some of it is still unknown of exactly where it was used. Another main big one we look at a lot is lead. So lead paint, which is architectural paints, primers, anti-rust, line markings. Um, Other uses is obviously lead in pointing, mortar, or stonework, lead dust in firing ranges, lead batteries, that sort of material, those sort of materials, sorry. Other hazardous materials that are common but not as abundant. Mercury, so all the liquid mercury switches, thermostats, thermometers, those sort of things. Mercury bulbs, so the mercury vapor in the fluorescent bulbs. PCBs, light ballasts, fluids and transformers, hydraulic fluids, all those sorts of things. Caulking and paint is another spot that we find PCBs in some instances. Then there's also ozone depleting substances, which are refrigerants in air conditioning systems or refrigerators. So once you know what you have in your building, the main part is to estimate the cost of the removal of these products and materials. The estimates we use are based on current prices, so present value, based on inflation, current values, current costs, that sort of stuff. Accuracy is highly dependent on the thoroughness of the survey and quantities that we've provided or have. The costs are normally based on Class D estimates, which is plus or minus 20%. So there is a high level of contingency in these. We use unit rates to calculate our remedial costs. So it's per material and condition of the material, not just overall assumptions. And then we also add contingencies to address exclusions or assumptions that may be present. There are a few caveats. To provide accuracy, we must carefully consider the regulatory differences. So that's by province, if you're a federal building versus just provincially governed, regional differences, even in areas, market conditions, contingencies, and then also published unit rates can be misleading sometimes. Pensions expertise, thorough understanding of local conditions, and internal data management and estimating tools will mitigate your variability compared to other options. Our process for estimating our costs are first, we complete a gap analysis. This is where we review all historical reports, historical documents, sampling, any kind of details and information you can provide about what may be present in your buildings. We identify gaps that may affect the outcomes. So if something is presumed, not known, that sort of idea. And then the gaps that we find will dictate how accurate we can be. Our next step would be a site review and investigation. This could include methodical sampling of some of the gaps, finding samples of materials that we didn't know, we aren't sure, were presumed before. We confirm quantities as well to make sure that they're accurate and up to date. And then obviously with laboratory analysis, we analyze anything new to determine if it is a hazardous material or not. And then we obviously do data management to give you a way to manage these materials long-term. The next step is applying our unit rates for each material that we do know is hazardous. We consider local and regional market conditions. And we also use our professional judgment expertise to make sure that just because the unit rate seems right, we make sure that it actually is valuable and helpful for you, not just throwing a number at something. And then the last step is obviously reporting. We establish the cost variance, so our Class D estimates. We add contingencies, and then we state all limitations that may affect our accuracy or what has limited our contingencies. So if we had to assume certain things, we add that to our limitations so everyone's fully aware. I'm going to go through 3 examples of ways that we do our cost estimates and modeling. The first example is we have a very limited inventory of our hazardous materials. The detailed inventory and quantities are not available, so we don't necessarily have a full building assessment. Um, the model is using buildings of similar size and construction type. This has a very high variability and it's not necessarily recommended. As an example, if you look at the diagram we have, the baseline A is used to determine the cost per square feet. And then with that cost per square feet, we take our existing building that we have for 100,000 square feet, multiply it by the cost per square feet and get 632,000. Whereas if we actually did the full process where we look at everything in the building, our actual cost would be down a lot lower based on known and not what's known to be hazardous materials and what's not known. Example 2 is a better option. We have a hazard inventory that's been conducted, but it is lacking some details. It has a majority of materials tested, but there are some gaps. So presumed asbestos, presumed lead. It has a good general description of hazardous materials and where they're located. It has limited quantities. Some of them are full quantities, some are limited, some are presumed. We do the same thing. We apply a unit rate based on our experience per material, not just per square foot. We adjust estimates to account for gaps and assumptions with the contingency. This version has a moderate variability, and I'll explain a bit more on the next slide. So this is our data that we have, for example, from an existing report. As you can see, there's a few lines that are highlighted as not tested, so they have to be presumed, which is where our 20% contingency comes in. So we had lead paint on the exterior that's presumed, cement pipe that we aren't positive that contains, and a couple of mastics that we don't know for sure. That's where it leads to the 20% variability. And it is your cost knowing that unknown with those unknowns, it can increase your cost because of the contingency added. Third, sorry, that's a duplicate side, I think. Oh, no, there was. The third example, it's the best option we suggest. It's a detailed inventory of hazardous materials, whether it's been previously conducted or gets conducted. All of the quantities are tabulated and reported of all materials that are known to be hazardous. The types and location of asbestos and hazardous materials are reported. Test results are included so we can confirm that stuff does or doesn't contain asbestos and other hazardous materials. We have detailed scale drawings that are provided. Ideally, inventory is in a tabular form, spreadsheet, or another digital format. Again, we apply unit rates based on expertise and industry standards, and this one provides the lowest variability. This is our third method. As you can see, there's only one material that's untested for the roof. Roofs are usually not tested because testing it can increase leaks to the building and cause issues for the building owners or tenants. But all the other materials, we have full quantities. We know what contains and what doesn't. So we can add our unit rates based on that. And then there is a small contingency added for the one system or the roof that's unknown, which is 5%. But because of this, our variability is very low because we know the actual cost based on the actual quantities and materials that are present. In summary, the main idea that we want to get across is that your inventory needs to be complete with minimal gaps to give you the best ARO costing and most up to date. It's important to understand local marketing conditions and regulatory landscape, as well as experience. It will all help dictate the accuracy of your ARO reporting. Assumptions and contingencies need to be clearly documented. This is just so that in future years, you know what was assumed one year that may change year to year. You can easily update and update the public sector boards of your changes.
Hi, everyone. I'm Nicola Hooper. I'm from our environmental due diligence group, and I'm going to be talking about the contaminated sites portion of this work. Can you go to the next slide, Mike, please? Okay. first question is, what is contamination? Um, Contamination is the presence of chemicals, metals, or pollutants which exist in soil, soil vapor, or groundwater in excess of the applicable regulatory standards. The regulatory standards are a risk-based measurement, which means that we can have contaminants below the soil and groundwater concentrations at the site, and the site would still be considered clean or an acceptable risk. If the concentrations exceed the standards at the site is considered contaminated. These guidelines, standards are scientifically based to protect human health and the environment based on the potential risk. So we're looking at exposure levels to human health and fish and wildlife. These standards are typically provincially regulated, so they are different from province to province. Next slide, please, Mike. I just wanted to do put this slide in here quick because there are two PS that apply to contaminated sites. So there is PS 3280, which we are here to talk about today, but it also includes PS 3260, and there's some variations. So for your ARO, which is PS 3280, it applies for a site that doesn't exceed and that doesn't have contamination that exceeds an environmental standard. So as soon as you have contamination on your property, you are actually looking at the contaminated site section, PS 3260, which applies. Next slide, please. Yeah. So potentially contaminated site versus an actual contaminated site. So what is the ARO evaluation process? It's a step-by-step process that we go through. It covers entire chain events from identifying a property that has a potential environmental ARO and taking it through the identification, assessment, and sampling up to the remediation plan. And it helps us develop a strategy for costing of how does that environmental liability gets addressed. And that would eventually form the ARO for the site if it's contaminated with soil or groundwater. It's anticipated that every property will go, it's not anticipated that every property will go through this entire process. Most properties will go through the first two steps, the property screening and the phase one environmental site assessment. Yeah, and those properties don't show a potential for significant soil or groundwater impacts. It's only the sites where the properties have that potential that will move forward further on into the process. And as you see at the bottom, the further you go in the process, the more time and resources will be needed. Next slide, please. The first step is a desktop screening process. This relies on information that was provided by the client. The kind of information we're looking for is when was the property acquired, developed, was the property previously developed, what was the historic uses of the properties and their on-site activities, including waste generation, chemical use storage, fuel storage. Are there any previous environmental reports that we can review or records available for us from their former operations? And when is the projected retirement date of this asset? The screening process will help us prioritize and select properties which require further assessment. We're trying to screen out properties at this point. If they're not screened out, then the next step that we have to go through is the phase one environmental site assessment process. Next slide, please. So the phase one environmental site assessment process, it is a regulatory process. So there's a standard for it that we need to meet. There are some main principles that we use when completing a phase one ESCA. That includes information and records review, the site inspection and interviews, and the evaluation of information and reporting. So we go to the property, we interview staff there, we look at their management practices, we complete a regulatory and historical record review where we search different databases, and then we compile a report. Where there is a potential for contamination, there are two ways that we can proceed. So if it's a lower risk concern, such as an on-site monitoring well, on-site septic system, etc., we can prepare an ROO at that time, a conservative one, and we will keep that letter on file. There isn't significant liability or risk to the property. You provide a justification of how you arrived at that conclusion in that number, and no further work would be required moving forward. So then you would be basically stop that process. If we don't find any potential for any significant risk at the site during the phase one, you don't have to proceed on with the ARO process either. However, if there is a higher risk activity at the property, we would recommend a phase two ESA. So things we would be considered higher risk would be underground storage tanks, former existing landfills, a lot of waste generation on the property, etc. Next slide, please.
Sorry, Nicola, there's just one
Yeah.
question in the chat. Can you please clarify for the arrow, is it defined that a site is contaminated only if it exceeds regulatory standards? Properties can be contaminated and can be contaminated and be below a regulatory standard. Is the trigger that it has to be removed, has to be remediated? Just because a property is above a standard does not mean that you can't use risk assessments to keep contamination no site. Can you please discuss?
So let's see. So I believe you can keep contamination on. So I do go into a bit more further into the presentation if we could just wait, if that's okay.
Yep, sure.
Okay, thank you. So what are the major risk factors that we're looking at? We are looking at the nature of the contaminants of concern that were identified during the phase one. Not all contaminants are created equal. Some move through soil a lot easier than others, potentially representing a larger risk and a more significant impact. Some contaminate soil and groundwater at low concentrations, so they would also represent a higher risk. So those would be like your chlorinated solvents, right? You only need a tiny amount in it to exceed the standard for like those in groundwater. If you have a contaminant of concern on site, they have the potential for the release. So that leads to the questions of like, how long had they been stored at site, and how were they stored? Next. So those are the things we're concerned about. Thank you. One of the activities that tends to be a high risk is fuel storage and fueling on site. And one of those highest risk operations are associated with the underground storage tank, UST. One reason for that is that the tanks are buried. So if there are small leaks or spills from the tank, they can't be seen and they can go on for a long period of time. They also contain fuel, which is like a high risk contaminant since it passes through soil easily and can impact groundwater for large areas. The pictures, oh, sorry. Can you go back? Thank you. The pictures you see here, like this is a public sector building. There was a fuel oil tank that had been replaced by natural gas. You can see the natural gas line in the photograph on the top left corner. And it had just been left in place for decades. This is a very common occurrence. A lot of times these older tanks weren't properly decommissioned. When we excavated it, it contained fuel and water, which wasn't a great sign because if there was water in the tank, that means it was infiltrating the tank somehow. You can see in the middle photo there, you can see a sheen on the water, which is a sign of potential impacts. And then on the picture to the right, you see all those little white dots there. That's actually sunlight coming through holes that were in the tank. Okay, next slide, please. So something we also look at is chemical and waste storage. Our chemical and waste storage practices are a lot different today than they were in the past. Today, it's heavily regulated with requirements for different kinds of storage, containers, labeling, manifesting. So there is currently like a much lower risk of release today. However, historically, there were little to no regulations for how these contaminants were managed or stored. So that creates a higher potential risk for release to the environment. Um, so what we're looking for is a larger quantity of chemical storage or waste storage at a site. We're looking to see how long the operations were present at the site, the volume of waste at the site that was generated, and all those things increase the potential risk for a release. And those are things we're looking for on-site and off-site properties. Next slide, please. For above ground storage tanks, they also contain fuel, but they are lower risk than underground storage tanks since there's less potential for the release to go unnoticed. We'd be looking for potential pathways. So you can see on the picture on the left, the tank is spilling, it's leaking, and it's going straight into a catch basin. So there's a potential pathway right there, where the picture on the right shows a double wall tank with containment, and there's no potential source of release there. Next slide, please. Stressed vegetation. This is something else we look for when we're completing our phase 1 environmental site assessments. We are looking for staining on poor condition gravel surfaces, grass, poor condition asphalt. We're also looking for areas of stressed or dead vegetation around a potential source, because that can indicate a potential leak as well. So you can see that transformer there has a patch of dead grass all the way around it. For us, that shows that like there was a potential release there. Next slide, please. So what does that mean? So we completed our phase 1. We looked at all these different factors, took them into consideration. And it looks like we potentially will need to do a phase 2. So a phase 2 is the actual sampling of the site to confirm whether or not there is contamination. So it's absence presence. If we do find contamination during our initial phase 2 site assessment, there could be a requirement that we need to do additional delineation to confirm the extent or the severity of the contamination. And we use this information to support determining the appropriate remediation and costs associated with cleaning up the property. Next slide, please. So phase 2 ESA borehole drilling. So this is one of the methods that we complete to get the soil and groundwater results. So essentially, we mobilize a drill rig, we pull it up to the site, we use direct push augers to go into the ground, and we bring them up like casings of soil, and we test that soil. We send it to a laboratory for analysis, and we get the results, and we compare it to the applicable standard for that property. And the pictures just show different ways we can collect the samples with different equipment. Next slide, please. Along with the borehole drilling, we can also install the groundwater monitoring wells. This is a case that goes into the borehole that allows water to enter into the well, so we can pump out the water and collect a sample. We use this to collect the groundwater for analysis that's sent to the lab. Next slide, please. Another way we can collect shallow soil samples is test pitting. It's not for every site. You need to be able to have a backhoe on the site and be able to make about a meter wide hole in the ground. So it's not for every property, but it is a very cost-effective way to collect soil samples. Next slide, please. So now that we have determined the extent of the contamination, we need to work on a remediation plan for the site. It's recommended to know the extent of the contamination, which would potentially require a supplemental investigation to delineate. Some factors to take into consideration for the planning is the cost to remediate the site, the disturbance to the site, the time frame available, and the future redevelopment land use of the property. Next slide, please. There are various types of remediation. Ex situ remediation means we're removing soils from the site. It's not always practical, but it ensures that all the remediation, all the soil from the site, all the contamination from the site is gone. So here's just a few examples of ex situ soil remediation. This one involves a backhoe. They are just digging out the contaminated soil, loading in trucks, and taking it away from the site. Next slide, please. Here's an instance where they are doing ex situ soil remediation, but they are the soil contamination goes beneath the building, so they have to excavate beneath the foundation. And this shows why it's not always a practical method, because this can be very costly, and there's a lot of considerations into this, such as geotechnical considerations, and you just want to make sure like the building is stable, so it can be expensive as well. Next slide. Here's an example of ex situ groundwater remediation. For this, it's an open excavation, and they are just using a pump to remove the water from the excavation. And they're going to be pumping it into a truck, which will be removed from the site. Next slide. And here is a different form of groundwater remediation. So this one is the water is being pumped out from the groundwater is being pumped out, and it's going through these different water treatment chambers where it's being treated before it's being placed back into the ground. Next slide, please. Alternatively, there is in situ remediation, which means on-site remediation. There are natural processes through biological and chemical degradation of contaminants that can lower the contaminant level over time, and it's called natural attenuation. Mother Nature does this naturally, but we can accelerate the process through bioremediation or chemical injections. This will shorten the amount of time compared to natural attenuation. It's still typically much longer to remediate the site this way versus ex situ remediation, but it might represent less disturbance to the site as well. Next slide, please. So risk assessment. At the beginning, I said the standards were developed using a risk-based approach. The risk-based approach that was used to develop these standards is called the generic standard. With the generic standard, they didn't take into account different factors like the depth of the impacts or whether the contamination is under a parking lot or a building. So we can use risk assessment to develop site-specific criteria, which might allow the impacts to stay in place, and you may not need to do any intrusive remediation. The remedial strategy so overall, your remedial strategy can involve all three of the different approaches I just explained. So ex situ, in situ, and a risk assessment approach. Next slide, please. So here is a sample of a remediation estimate that we would be providing you. It provides numerous different options that would work for the site. So there's different alternatives, 1, 2, 3, and 4, and they are a mixture of the 3 different approaches that I just talked about. This cost sheet describes the different costs, both the initial capital costs as well as the annual costs over the duration of the project. It also identifies the total number of years of operation of this project would take, and it would be up to the client to select the remediation strategy that makes the most sense for them. And that's the total that would be carried for the ARO. So does this answer your question, Janet? So you are allowed, I believe you are allowed to use a risk management approach.
Yeah, the main thing is the arrow isn't triggered by contaminated sites or hazardous materials on site. It's triggered by any retirement of a public sector. So her answer was no, it was in relation to the earlier statement as to when a site is contaminated.
It was contaminated. So a site is contaminated when it exceeds the regulatory standard for the site. And the standards are different for each province. And are you asking if you have a risk-based standard, does that mean you don't need to carry a cost for an ARO? Is that what you're saying? You would still need to carry a cost because there is a cost associated with the, okay. Yes, I'll follow up with you afterwards, Janet. Thank you. Okay. Next slide, please. Oh, so this is just a decision tree from the BDO that they've put out, which walks you through the different obligations for your site. So it's just a little yes, no decision tree. And it just lets you know what section of the PS, like PS 3280, PS 3260, or PS 3200 that you would be using when you're doing your form. So they're kind of interconnected. So this is a good way to sort of figure out, okay, so what are my asset retirement obligations versus what is my liability for the contaminated sites, and when does that apply? So next slide, please. So landfill closures and post-closure liability estimates. We do have a landfill expert, and if you have questions on this, I can get you the contact for that person. This is not my area of expertise, so I'm just going to go through it in as much detail and quickly as I can. So landfill, so waste disposal sites, like, are they assets? They are assets. So there's been a mind shift recently that this isn't just a dump. This is placed as an asset. There's a lot of considerations for a waste disposal site and costs associated with them. The replacement expansion of the landfills, they can be lengthy and difficult processes to get approved. The operation of the landfill itself, there are ways to optimize the operation to maximum the life of the asset itself. And there's also closure requirements, environmental and regulatory things that we need to consider. So next slide, please. So a waste disposal site is an asset. We did a feasibility study for a smaller community of about 3,000 people. We were trying to figure out what the best waste management option for the community was. We were trying to determine, do they want to invest their money in expanding the landfill, or to try to get a new landfill approved, or to abandon the landfill altogether and looking at hauling waste to an adjacent community and paying for that disposal. In doing this exercise, we pulled out various stats, like the typical tipping fee, how much per person of waste we typically generate per year. And it was determined that the cost for each person per year would be about $60 to manage that like they would get in revenue for a waste disposal site. So for a town of 3,000 people, that's $180,000 in tipping fees alone. And if the landfill has another 15 years left of capacity, that's an asset that's worth $2.7 million. Um, yeah, sorry. So if you don't have a landfill, it'd be a considerate investment to deal with disposal of waste material. So if you have to ship it off to another municipality, it's going to be a huge investment for that community to cover those costs. Next slide, please. For closure costs and post-closure liability, you need to know where your landfill is at today. All landfills have limitations on them, whether it is the amount of waste that you're allowed to receive by volume, or it could also be based on the areal extent. So like you could have a limitation that your landfill it can only be 2 hectares large. There's also height restrictions, slide slope restrictions, crown restriction, and regulatory setbacks. Most of the time, these will be specified in your licenses for your landfill. So this little picture below, this green line here shows the current level of the landfill. The red line here shows the remaining airspace that's allowed under their license. And they were looking into expanding their landfill, getting an proposed extension. And to do that, we needed to determine the volume of waste that could handle, and we need to convert that into like how much per year. So next slide, please. So one way we do the volumetric lifespan of a landfill is to do an annual topo survey. By doing this, we can calculate what the average waste deposition rate would be. So we're looking at our past information to determine how much volume is being placed annually. All the waste is measured when it gets to landfill on scales, but the weight of the waste isn't always the same as volume of the waste, right? So things can be lighter but bigger. So this is a good way for us to determine what that annual waste deposition rate is. Next slide, please. Okay. So this slide shows the different phases. It shows a development plan and an operation plan for a landfill. It shows the different phases that we can help you determine and recommend. So in this first slide here, the first phase here would be to do this top corner here. And by doing this planning, it allows us to also like cap to go. So you will use one section of the landfill first, fill it up to capacity, cap it, move on to the next section, fill it up to capacity, cap it. So it's one way we recommend creating these operations. Next slide, please. Contaminating lifespan. Another thing that's important is the contaminated lifespan of the landfill. The landfill is a significant source of potential contamination. When it rains, it will create leachate, which will potentially enter into the groundwater. So you have to have a leachate management plan for the site. So it's something that you need to considering. So that's the monitoring, compliance, and reporting costs for the site. You also need to consider the contaminant lifespan. So how long are we anticipating that the contamination is going to be generated at this property? The standard default for this is 25 years post-closure. but that is an estimate. It could be longer than that as well. Next slide, please. Okay, the closure concept. There are closure costs associated with closing a landfill. Most jurisdictions require that some sort of cap or vegetation is placed on top of the landfill when it is closed. And this is why there are advantages to doing the progressive closure of the landfill or doing the phased closure of the landfill. So like working section by section by section. In doing so, you eliminate some of the risks such as airborne litter, which is picked up by the wind, eliminates the risk of potential fires and reduces the amount of animal tracks that you can get. Other aspects is that you can close cells in accordance with your development plan. So you don't have to carry those costs in your post-closure liability because they're already closed. So it's important to try and develop the site and close the site in a specific sequence so you don't have to account for it in the long run. Next slide, please. Post-closure care. So these are certain things that are required under your license or by your municipality when you close the landfill. As we discussed, there is the final cover and vegetation, and those need to be inspected and maintained. You have to make sure you're maintaining all the infrastructure at the site, including the roads, fence, gates. So these need to be inspected and maintained. You need to keep up with your water quality monitoring and reporting. And you also need to carry a contingency in case there's future impacts to the subsurface or groundwater, or there's acquisition of additional buffer lands that need to be happened. So you have a higher concentration than you had previously accounted for, then you need to carry costs for that as well. And that is everything I have. Next question.
Were there any questions that we didn't cover? I'll just reiterate that the ARO is not triggered by just because you're contaminated or have hazardous materials. If you own a building that is a tangible asset, even without asbestos or hazardous materials, there is an ARO cost that's associated with it. What we're speaking on is obviously the more impacted and hazardous materials and contaminated sites that require specialized ARO pricing versus just general demolition or general care and asset retirement. If there's no questions, we'd love to hear any of your feedback. If you need to contact us in any way, you can reach us through our website. I believe both Nicola and I are on LinkedIn as well if you need to find us. And again, this whole presentation was recorded and will be posted on Pynchon's website and also a few links on our socials. Thank you everyone for attending. With no other questions, I believe. Oh, sorry, a couple questions in the Q&A. Sorry. Oh, I don't believe we will be issuing a PDF of the presentation. I think we just do the recording of the session. Okay, well, thank you everyone for joining. Again, if there's any questions, please don't hesitate to reach out to us. And thanks again and enjoy the rest of your day. Oh. What happens if the contaminated site is sold? I believe that would just be the ARO requirements would be the new owner's requirements and no longer the previous. Nicola, do you know any different? I would assume it's the same thing, just like if a property sold, any contaminants on the site would be their requirement now, not the previous owners.
Right. So if they are purchasing the site, I believe they're accepting all liability for the site unless it's written in their agreement. And then you would have that contractual obligation that we talked about as one of the AROs. Yeah. Okay.
Perfect. I will end the session. Thank you, everyone.
Thank you.